Hello and welcome back to the practice dilution problems solution video from Genetics Lab. This is just problem 5, part C. Again, the best way to solve these problems is to start with IC equals FC times DF. Now this is a problem that looks very tricky and certainly has upset many students over the years, but really it's not nearly as bad as it looks. It says you start with a culture flask containing E. coli at a concentration of 4.5 times 10 to the 8th colony forming units per mil. Diagram how to dilute it so that we can spread 0.1 mils from one of the tubes in the dilution series such that it contains 30 colonies, and spread 0.1 mils from another tube in the series that it contains 150 colonies. Okay, so that sounds really bizarre, right? I mean, my God, what do we got to do here? We're going to be we need two different concentrations and two different plates. Okay, well, that's fine, right? We're doing a serial dilution, but all this means is that we need to predetermine the concentration of two of the tubes. That's all this means. And we know that the one that gives us 30 colonies is going to be the most dilute one, right? That's going to be the last one. The one that gives us 150 colonies is going to be less dilute, right? So it makes sense to start with that one. The one that gives us 30 colonies is going to come from the one that is going to come after the one that is giving us 150. So let's start with the one that's giving us 150 colonies. That's going to be a little easier. And you know, this is exactly the way we just did 5A and 5B. So this should be really familiar to you if you just watched, or if you have watched, the other video. And if you haven't, I strongly suggest you do. So let's start right there. We have IC, 4.5 times 10 to the 8th colony forming units per mil, and we're going to be able to get FC because we know that we have 150 colonies coming from this tube. So we know we're going to be able to get FC, and so that's really good. Okay, we're in good shape. So where should we start? Well, we even know what we're going to plate this time, unlike with tubes problem A and problem B. So if the FC is the concentration in the last tube and we're plating 100 microliters or 0.1 mils, then 150 colony forming units per 0.1 mils means that our final concentration for this tube, the one that's giving us this, is 1.5 times 10 to the 3rd colony forming units per mil. And just like with part A and part B, we can use that to figure out the dilution factor we have to use to get there. IC over FC equals DF, right? If IC equals FC times DF, we just divide both sides by FC to get our DF. And so IC equals 4.5 times 10 to the 8th. FC is this, 1.5 times 10 to the 3rd. That means DF, units cancel. DF is 3 times 10 to the 5th. From our earlier experiments, we know, problems, we know that we can do this dilution in lots and lots of different ways. The easiest way is to take out 1 to 100 dilutions because we know how to do them, and then see what's left. So we could do a 10 to the 2, a 10 to the 2. What's left over is a 1 to 30, right? So this is a nice, easy dilution series to do. That will get us this, which is what we need to do that. That's our final concentration to make a tube that'll give us 150 colonies when we plate 0.1 mils. That's one of the things we need. Alright, that's half of the problem right there. But now we need a tube that'll give us 30 colonies. And so what we do is we do the problem again, except for now the tube that was our FC becomes the IC. We do another little dilution problem. And we create a new final concentration. This time our new final concentration is based on the idea that we need something that'll give us 30 colonies. So if it will give us 30 colonies on 0.1 mils, from 0.1 mils, what's the concentration in that tube? 30 colony forming units per 0.1 mils means it must be 300 colony forming units per mil. So once again, IC divided by FC equals DF. What was FC last time is now IC. Our new FC is 3.1 times 10 to the 2, or 300. That gives us our new DF. 1.5 times 10 to the 3 divided by 3.0 times 10 to the 2 is 5. And so we know that we need to do a 1 to 100 and a 1 to 100 and a 1 to 30 to make a tube that will give us 150 colonies, and then we need to do another 1 to 5 dilution to give us a tube that will give us 30 colonies. And so there are lots of ways to do different dilutions, of course, but here's a way you could do it. 10 to 990 is a 1 to 100 dilution. 10 to 990 is a 1 to 100 dilution. 10 to 290 is a 1 to 30 dilution. That's your IC and your FC to get to that get through that dilution series that gives you 150 colonies on a plate when you plate 100 microliters. This becomes the IC and the FC to figure that out. 100 microliters into 400 microliters is a 1 to 5 dilution. Of course, there are lots of ways to do that too. 200 microliters into 800 microliters, whatever you like. 1 mil into 4 mils. And then when you plate 100 microliters, you should get 30 colonies. I hope these solutions help you. If you're still having some trouble, please do come and see me or one of your TAs. Please do the problems on the practice midterm or last semester's midterm or final, problems on the web, other quizzes, and then bring them to me or a TA and let us help you with them.